452, that slope activity, you're going to see an attached PDF that's going to look something like this. It'll have 4 different cards in yellow, and you'll have 2 different sheets of yellow. You have orange cards, you're going to have green cards, you're going to have a purple card, and then you're also going to have some blue cards. What you need to do is do 3 of each color card. So I'm going to do card 19 for you, the yellow card. So when you're filling out your 5-2 worksheet, you're going to put 19, that's the card number, and it's yellow. That way you only have to do 2 yellow. I'm also going to do an orange, that way you only have to do 2 orange. When you're looking at your work, all of these are calculating slopes. So all of the yellow cards are going to be slopes on graphs. All of the orange cards are going to be tables, stuff that you kind of did in your IXLs. You're also going to have 2 ordered pairs, or the slope, find the slope or the rate of change between 2 ordered pairs, and your green. Your purple, you're going to look at comparing 2 different rates or 2 different slopes and then kind of writing that out. And then the blue is other word problems. So looking at card 19 and the yellow cards, what we're going to be doing is calculating slope or rate of change on a graph. There are a few different ways that you can do this, and I'll show you both ways. You don't have to show both ways, just pick one. So you could do rise over run, or you can do between 2 points. So using the actual slope formula, your y2 minus y1. Remember, we're doing y2 minus y1 over x2 minus x1. Or you can do rise over run. However you see fit, whichever one you want to do. So looking at card number 19, we're riding a bicycle, and this is how fast. Remember, slope is a rate. It's how fast we're traveling. So I'm going to look at my graph and say, okay, well, I have 0, 0. Obviously, we're starting at 0 miles and 0 minutes. And I have one other point here at 60, 16. And I have another point here between 120 and 32 miles. So we have 60 minutes, he traveled 16 miles. We have 120 minutes, he traveled 32 miles. When you're doing rise over run, so you can choose whichever one. So I will do rise over run first. So when you're doing rise over run, be careful with how much you rise and how many you run. You need to pay attention to how much is between each one. This isn't just going up 2. Looking at the difference between 32 and 16, these are all going up by 8s. So we're actually going to go up 8, 16. So we're going to have 16. And we're going to run. We got to make sure we're careful on how much we're running here, because I'm going to go up 16 and to the right. Well, each one of these is 20. So we have 20, 40, 60. And since we're going to the right 60 minutes, because that's from 60 to 120, it's a difference of 60 minutes. So we're actually going to go over 60. Now, 16 over 60. So that means that he's traveling 16 miles over 60 minutes. However, slope and rate of change, I don't say that I'm going, when I'm talking about how fast I'm traveling, we're always going 60 miles an hour. That means every hour we're going 60 miles. I want, how much am I going per every 1 minute? So how fast is he traveling? So what we're going to do is divide these out, and this is what you did on your IXL. So I'm going to take 16, and I'm going to divide it by 60. And I get 0.2666 repeating. So I'm going to round this to 0.27. So what this means is that since we divided it out, this is how many we went up miles per minute he's traveling. So we have miles on my Y per minute on my X. Whatever our Y is, because we did rise over run, that is going to be our actual values and our labels for our slope. So I can say, okay, well, the cycler is traveling, and we can say 0.27, this is 0.27 miles every minute or per minute, whatever you want to say, per minute or per mile, or sorry, per minute or every minute, that works. So you could also use your two ordered pairs here. I could say, okay, well, I'm going to take my y2 minus my y1. So I'm going to take 32 minus 16. So I'll just y2 minus y1, x2 minus x1. We'll do 32 minus 16 on the top. And we're going to take 120 minus 60 on the bottom. And just like you did in the IXL, I'm going to use my calculator here. So I'm going to divide. We'll take 32 minus 16 on the top. On the bottom, we'll take 120 minus 60 on the bottom. And notice we get the same exact answer. 0.26 repeating, or we'll just round and say that he's traveling 0.27 miles per minute. So whenever you're looking at slope, this is how we always want to look at answering or explaining what it means. Explaining what it means, we have our y over our x. We're traveling miles per minute, or if this is hours, we would have miles per hour here. But here we're just traveling miles per minute because those are our labels. Now I did one yellow for you. You're supposed to do two more yellows. So moving on, I'm going to leave two blanks for you so that way you have your two blanks. I'm going to move this up. So you should have another yellow. You should have another yellow here. So pick two more, and you do the same exact thing. Whichever one you choose. You could do rise over run, or you can use your slope formula. Either one works. Just make sure that when you're interpreting it, you have miles per minute. Okay. So now I'm going to do an orange one, which is going to look a little different. So I'm going to write 11. This is orange. All right. So we have... Table shows the amount of money a car salesman earns given the number of cars they sell. Calculate the slope and explain what it means. So for this one, I'm going to use two different values, and I'm going to use my y2 minus my y1 over my x2 minus x1. Remember, this is your x, this is your y. So we're going to have our paycheck over the number of cars sold. So I'm going to use y2 minus y1 over x2 minus x1. And you're just going to pick any two that you want. Doesn't matter which two. As long as you're going to subtract the same, that's all that matters to me. You could pick these two, you could pick these two, it doesn't matter. I'm just going to pick the first two, just so it's easy. So I'm going to pick these 2 points here. So these 2.6, 2,500, and 12 and $4,000. What this means is that he sold 6 cars, so he made $2,500. He sold 12 cars, so he earned $4,000. I want to figure out my slope, or my rate of change. When we're talking about this, we have my cost, or the amount he earns per car. So we want to figure out how much does the salesman earn per car. So every car he sells, how much is he going to be earning? That's what we're basically trying to figure out. So I'm going to take 4,000 minus my 2,500 over, and we're going to take 12 minus 6. Get out my calculator again. And just like you did in the IXLs and the practice, we're going to have 4,000 minus 2,500. And we take 12 minus 6 on the bottom, and we get 250. Okay, so what does that mean? Well, 250, this was dollars, because we took $4,000 minus $2,500, and this was the amount of cars. So when I took the difference and then divided them, this is going to be my dollar amount. This is how much he's earning per car. So we can say that the salesman earns, and I'm going to have you fill in the rest. So the salesman earns how much? Well, that's $250 per car, or for each car that he sells. So for each car that he sells, the salesman earns $250. Or you say the salesman earns $250 per car that he sells. you're going to do 2 more oranges. So you're going to pick 2 more tables, just like this, and you're going to do the same exact thing. Just be careful that when you're looking at some of these, that you take a look at your y-axis and your x-axis. Because some of these are going up by 1s, but some are not going over by 1s. These are going over by 10s. Or here, these aren't just going up by 1s. So make sure you're careful and count to see what your x and y axis are. When you get to your green cards, which is after the orange, you're going to be doing the same exact thing, but you're going to be finding the difference. It actually gives you the ordered pairs already. So you're just going to use your slope formula again. For your purple, here's going to be a little tricky. So here we have 2 different lines. Okay? When you're looking at your 2 different lines, you have the number of miles the Penningtons and the Williams have traveled over the given number of hours. So we want to compare their 2 rates. Remember, their rates is how fast they're traveling. So how many miles per hour are the Penningtons traveling, and how many miles per hour are the Williams traveling? Figure out who's traveling faster. Compare the 2 rates. So find each rate and then compare the 2. Doing the same exact thing like we did on the yellow cards. If you have questions, feel free to ask. I'll be around to help you out.